Hi class, this is part 2 of the simple stain. So I placed the microscope slide, the simple stain, on the stage, and it's in the clips, microscope clips. And so now it will move when the stage moves, so I can move it forward and back, left and right, and that's with these knobs on the right side of the microscope. And then there's the condenser. It's down below here. This is the condenser, recall, and we can raise it up. And so we want it to sit up pretty much almost to the slide. Okay, and then the iris diaphragm, put it about halfway for now. We might increase the light up here a little bit more. And then we have the focus. This is the coarse focus on the inner ring, and then the little tiny knob is the fine focus. All right, and so when we look at this, we want to first put the drop of oil on. Okay, so here's the oil. We just put a drop, and we don't let it hang and drop off. We actually touch it. And so it's about this big around, just barely on there. And now we can turn it to the oil lens without dragging any lens through the oil. And then we're going to bring the slide up. And so I want you to pay attention to this surface right here on the slide, this edge. And we're going to see it flash when my lens goes into the oil. See that? That's it. That's when you stop. And notice I haven't looked into the microscope at all. Okay, and from here on out you have 4 turns on the fine focus. So the fine focus is right here, the smaller knob, and we can go 4 rotations, complete rotations forward. If we don't get anything in focus, then we'll go 4 rotations back to neutral, and then 4 the other way. So we can go 4 positive, and back to neutral, 4 negative rotations. And that's it. That's all you're allowed to do. If you do any more than that, you are at risk of lowering this lens into the slide, and it will crack the slide, break the slide, so then you have a contamination issue, possibly. But worse, you have possibly a damaged lens for the objective lens. And these are well over $100, I think. At least 100. So they are expensive. And so we want to make sure we're taking care of it. All right, so now we just come in and we look at this, and when we're looking at it, when we have our eyes looking at the ocular, we only can do the 4 turns forward and then back to neutral, and 4 turns the other way. All right, so let's see if I can see something. Okay, and it was just about a 1/4 turn. And I see lots and lots of gray rods, and then it's a little bit washed out, so I'm going to reduce the iris diaphragm to get a little more contrast. All right, and that's all there is to it. So by using this technique of having a flash, and then you can see the sample. All right, so I'm going to stop the video, and then I'm going to get it set up so that hopefully we can see what's in there on the microscope. So this is the view through our microscope lens of Escherichia coli, E. coli, simple stain. Okay. Later on, when you do a gram stain, the fact that it is a certain color will determine whether it's a gram positive or gram negative. Gram negatives are bacteria that live in the intestinal tract. Gram positives would be on the outside generally, in your nasal passages, your mouth, and so forth. All right, and so I can, manipulate the fine focus a little bit. I can play with the iris diaphragm, and it just makes it darker and pinker, so we don't want that. We want it just a true white color with just the stain showing. play with the condenser. Lowering the condenser makes it a little less light. You can you want it pretty much all the way up, and the rheostat all the way up. Then you can take your stage control and just scan around to see if there's anything contaminating that. You know, we picked it from a pure colony, and this looks pretty good. The bacteria are all rod shaped pretty much, short rods. They're about 1 micrometer wide again, and 4 micrometers long. There's a couple of these that have just divided. You can see them kind of pinched in the middle. That means they're just divided. And these bacteria divide by binary fission, not by mitosis that you learned in cell biology. This is bacteria divide by a process called binary fission. Okay. And the chromosomes on bacteria are what? And so then that's something you can look up. All right, everything looks the same, so it looks like we have a pure culture, and we can call it that. So we have a pure culture of E. coli in a string K12, so it's not the E. coli that makes people sick. Although if you ingested this probably would give you a little bit of intestinal issues, but not greatly. It's designed and genetically engineered so that it will no longer colonize or grow in the intestinal tract, so it would just flush through. Okay, we'll do more slides later on, but that's it.